Hi, welcome to day 3 of Rapid Plus TCT 2022. I'm Brandon Ribic, the Technology Director at America Makes, and I'm really happy to be joined here by my colleague and friend, Howie Marotto from EWI. How are you today, sir?
Yeah, I'm well, Brandon. Thanks for having me on the show. It's been a good event so far here at Rapid TCT, and I'm really excited to talk about some things we're working on with you all and some things we're doing at EWI as well that I think will interest the America Makes fan base that we're going to be talking to here today.
Yeah, great. No, it's good to see you. It's so nice to be out in person, right? I mean, my goodness, it's, I think, long overdue. You know, Howie, one thing I heard about this week quite a few times is cold spray. You know, in fact, even I think Brian Bauman talked a little bit about it, the value for, I think he brought up repair.
Right.
But I think that's something you're doing a lot of, right?
So, yes. So cold spray for repair, cold spray for exquisite coatings, potentially, and cold spray for additive as well. So we're looking at all facets of it, from high pressure to low pressure cold spray, as well as cold spray for additive. I think you probably know this, and some of the audience probably knows this, but cold spray for additive is probably, well, not probably, it is the fastest form of metal additive manufacturing. So there's a lot of potential there. However, because it's so new, I think there's a lot of opportunity for us at EWI to help people understand where that makes sense and where it doesn't, what materials to use and what ones really aren't ideal for it. And then, you know, what the qualities, the material characteristics that you would get from using cold spray for additive. So we're really excited about bringing that capability to EWI at our Cold Spray Center of Excellence up in Buffalo. But there's also a lot of buzz around cold spray, not only for repair. I mean, I think people have known about that for a while, and coatings, but particularly for high velocity systems. You know, as we look at more exquisite metals or alloys, it's very expensive to machine those, to cast those. Sometimes they're not really ideal for casting. Things like titanium, right? And sometimes the supply chain isn't there. I mean, we probably, it's kind of like the elephant in the room. It's been hanging over our heads. That's why additive appeals to a lot of people, is because of supply chain challenges, and we've seen that get worse. And particularly for certain alloys and metals. So I think where I see a lot of potential, and as I said, on high velocity systems in particular, is we don't have to make a component completely out of that metal. Maybe we can use a base metal that's less expensive, but just as strong. And just coat it with whatever that alloy or metal is that we need for example, heat resistance. So I think that's where cold spray may come into its own, as it can address a lot of those supply chain challenges, also the manufacturing challenges. So super excited to be developing our center up there in Buffalo to get after those challenges.
No, I think you bring up a great point. So I mean, thermal protection purposes, oxidation resistance, but you know, I think another thing we heard this week, and I know this is something that you and I've discussed before, is how we use additives. So Speed 3D gave a presentation on some work they're doing with the Australian Army and trying to deploy cold spray in the field. Are you seeing anything like that as well? Or?
Yeah, so as many, again, a lot of the America Makes folks know, I'm also a colonel in the Marine Corps in the reserves. So, you know, in-field additive manufacturing is absolutely on all the services radar. It has been for some time. But I think now we're finally starting to see some of that transition, like the Speed 3D system with the Australian Army. You know, the American military is very interested in that as well. And I think hybrid additive is going to kind of come into its own. I think we're seeing a lot more buzz around that. Again, it's been out there for a while. But I think people are now finally starting to see, well, this makes a lot of sense in a deployed setting, but it might also make sense in a factory. If you, or a depot, if you're the Air Force, right, or a repair facility, because you probably already got a lot of CNC machines. So if I can repurpose them or add another tool to the tool exchanger, right, that happens to be a wire-fed direct energy deposition head, so that I can now lay down a metal component or casting and then machine it right there in the same machine. I think hybrid additive has immense potential to grow significantly in the coming years, just because it's an easy conversion for a lot of folks that are doing conventional subtractive manufacturing, and because really I think the cost point's going to be a lot lower than some of, you know, your powder bed fusion systems or some of the higher end DED systems where you need a vacuum.
Yeah, So in terms of DED, are you doing DED research at EWI?
We are doing a lot. We're very honored to be working with Sayaki.
Okay.
But we're not limited to working with them, but we're doing some really interesting stuff by sensoring up the machine. Obviously, when you're working with those kind of temperatures and in that type of a vacuum, it's very hard to actually do in situ monitoring.
Okay.
But we are actually doing that right now.
Cool.
There's a lot of challenges because of, again, the vacuum and the way that when you do that form of E-beam additive, that there's splatter, there's all kinds of issues. But yeah, it's pretty exciting. And we got a powder blown DED system up there as well that we're censoring up as well, right?
Okay.
But it's not that people haven't tried to do it or don't want to do it. I think that we're just trying to take it to the next level.
Sure.
And I think the results are going to be pretty informative and maybe game-changing for that industry. I know that a lot of the manufacturers are very interested in what we're doing because it's things that they've wanted to do but maybe haven't been able to do.
Yeah.
And we're just combining the unique expertise and skill sets that we have from a variety of fields in EWI to do that with our data science guys. Big shout out to Alex Kitt. A lot of the America Makes members know Alex. He's been a big part of this. And really collecting that data and then actually turning it into something useful. Again, I think that's something unique that we bring at EWI, and that's what we're doing with a lot of our DED systems, is to take them to the next level and really get after in situ qual and cert and monitoring. So yeah, I think that's probably the most exciting thing right now.
That's awesome to hear about. I mean, we just had a conversation here a little earlier about the digital thread and a lot of discussion around monitoring. But I think you bring up a very important point about integrating sensor technology into these equipments, into these operating environments that might not be conducive to sensoring, right? And so there's a lot we need to do there.
And that is what we're really trying to focus on.
Okay.
Another thing that we like to do, obviously, is we have a lot of our open architecture systems where we try to replicate a capability, but we do it in-house so that, again, we can sensor it up and do things that maybe you wouldn't be able to do with an OEM system, or you wouldn't want to do with an OEM system because that's your production system.
Yeah.
And sometimes even the OEMs don't want to do it. So yeah, really enjoying that space right now because I think there's a real need, but there's not a lot of people addressing it.
Okay.
Yeah.
All right. Are there any other types of additive that you're looking at EWI?
So, I mean, we do all types of additive, all modalities of additive we have. I think, we hit on a couple of the exciting ones. What we're doing with cold spray, what we're doing with DED and E-beam, what we're doing with the hybrid piece. But I think, and this is a bit of a shout out to Fabrisonic. It's not quite EWI, but ultrasonic additive, I think, has a lot of potential too when we start talking high velocity systems.
Sure.
Or any type of system that really has space restrictions. In other words, if everything now is a computer. There's all kinds of wires. There's all kinds of internal controls, thermocouples and sensors, in a lot of our advanced aerospace systems.
Sure.
And how do you manage the materials and the space and make it all functional when you really don't have a lot?
Yeah.
So I think Fabrisonic, which again is partnered with EWI, it's basically a spin out, is doing some incredible stuff in the ultrasonic additive space. That I think if you can embed wires or thermocouples that you would normally not do into the actual structure, you can save a lot of space and potentially weight. And I don't know of any other additive process, other than ultrasonic, where that's very viable.
Yeah.
So that one really excites me as well, in addition to all the other technologies we have. And I'm glad that we're a partner with Fabrisonic and that they've taught me a lot and I'm learning more. And I think as the demands grow, as we look at higher speeds or going into outer space, I think they're going to be that form of additive is going to be critical.
Yeah, I agree. I mean, I think, we've been really happy too to have some collaborative efforts with them. They're developing some materials allowable data right now on a project with us that I think they started about a year ago now. So we're looking forward to kind of understanding that and learning more. I know Mark presented at the TRX, so it was good to see him.
Yep.
In terms of, so you mentioned high speed or high velocity applications, thinking about the ability to additively manufacture structures that involve multiple materials, multiple subsystems, various functionalities. What do you think about those technologies for, like, you mentioned electronics, but what about electronic vehicles? Are you seeing anything there?
So we are, and maybe in some more mundane ways than people think, but when you build a battery cage for an EV, that's important because obviously there's a lot of concern around battery safety.
Okay.
And I think with some of our solid state welding and some of the options you have with topological optimization, thanks to additive, I think, again, it may be mundane, but I think the battery cages are going to be a great application for additive in EVs. Okay. There's a few people that have been dabbling with additive for batteries. I don't know that we're there yet. I think maybe 10, 20 years, that could be a viable way to manufacture batteries, but at the volumes we're going to be talking about, I'm not sure it's quite there yet. And it's an interesting thing about EVs as well. You would think, well, maybe using additive and topological optimization to lightweight an EV would make sense because the batteries weigh so much. But we've kind of so far seen the opposite requirement in industry. They've become less concerned with weight now in some ways. It's interesting.
Huh.
So there's a conversation, of course, about lightweighting right now, and EWI is blessed to have a great relationship with the automotive industry,
okay,
and we have for many years. So I think it's going to be interesting to see how weight plays out in the EV world, whether the manufacturers just decide that, you know what, we can just use steel and steel frame because the vehicle already weighs that much anyway, so what's another 1,000 pounds of material, right? Or you might see some companies try to differentiate themselves by saying, okay, they've accepted the weight, we are not. And if that gets us 10 more miles of battery range, then maybe it's worth using topological optimization and additive to produce that frame. And so I think it's going to be interesting as the EV community develops, and obviously we all know how hot it is right now, to see which direction manufacturers go, because I think we're going to see people going both. I think the majority are looking at, well, weight's not an issue because the battery's already heavy, but I think there'll be somebody out there who says, let me look at additive and try to do this a little lighter and a little better and just as strong. So I'm guardedly optimistic it'll go that way, but I'm not completely sure it will. But so we'll see.
Yeah, I mean, I think this week we heard a couple things about that as well during the event, and productivity has definitely come up. So we all know that that's an ongoing focus area for additive technologies. I think something though, based upon your comment about the batteries and additive, and if it does take, I think you said 20 years. I think that may line up very well because I think there were some comments Monday. On a talk about EV vehicles and how there's an expectation that in about 15 years or so, the majority of new vehicles being sold on the market will be electronic vehicles versus combustion engine vehicles, and at least that seems to be the current trend. And so it may line up perfectly.
It could, and I think the other opportunity for additive in the EV space is as that volume. Right now, I think the volume's low enough where you might be able to incorporate additive into the production of every EV vehicle even now because the volumes are that high. But in 15 to 20 years, as the speed of our additive processes increases, and we start incorporating things like maybe cold spray for additive, which is very fast. You're right. I think those technologies might line up, and that we might see a revolution in the manufacturing of vehicles from very traditional manufacturing, the way we've been basically doing it since the 60s, to a new way because EVs are going to drive a lot of those changes. Again, we won't know for a while, but I think you're right. I think it could line up very nicely. So,
one other thing I wanted to ask you about. So, folks in the community have been talking a lot about casting and forging replacements. I think casting longer than forging, but anytime there seems to be a gap in what they can readily get their hands on in the supply chain, it's how do we bridge that gap? And then, of course, are we actually able to, especially when it comes to wrought product? I mean, the quality standard there is very, very high. Are you looking at that at all at EWI?
We are. I think when you talk about the quality as compared to wrought, of course, we're always trying to validate new materials or existing materials that have been used for a long time and say, yes, we can achieve those kind of properties, whether it be with laser powder bed fusion or DED or another form of additive. But I think, too, one of the challenges there too is because they've done it, we've done it, manufacturing has done it that way for so long, it's hard to overcome the bias towards that. And we like rot because we understand it, but maybe, I think, and I've talked a lot about this at different organizations and even standards organizations, that maybe the standard isn't right. Or maybe we base the standard off of rot when it never had to be that extreme, if you will, or that strong. Maybe we can re-look at the standards throughout it. And that's a challenge, though, because you have to overcome that institutional bias towards rot.
Yeah.
And so, not that we don't think we can achieve rot properties in many cases, we think we can, but it's going to be a lot slower in many cases. But I think, is that always the answer?
Sure.
Or maybe we need to start looking at different standards. And I don't say different standards for additive, I say different standards for our vehicles, different standards for our products, and saying, does that make sense anymore?
Yeah.
It might have made sense in 1950 or 1960, but does it make sense now? Particularly because additive opens up the potential to use other materials, other than aluminum and steel.
You're absolutely right.
And so maybe we can even use better materials at less cost that give you better properties, so why would I even worry about matching rot steel when I could use a better material that has better properties by the nature of the material?
Sure. No, and I think there's been a couple of good examples of that that we've seen in some of the technical program this week, of trying to understand those trade-offs. And then furthermore, it's kind of a collaboration example, right? You have to work with your partners, those with the design authority, to say, all right, this is where we are.
Right.
How do we work with that? How do we change our standards and expectations for design or the allowable, right, that will allow us to move forward?
Yeah, and I think that's why we're really focusing a lot on in-situ monitoring and sensors, because it's a lot about trust as well, right? And I think just building trust. I mean, I think those of us do additive, trust additive.
Sure.
But I think if it's not something that you grew up doing, you don't have a lot of trust. So the more data we can collect, the more sensors we can put on the machines, just to build up that trust. Maybe even prove something we already know is true, but now you can see it as it's happening. People will feel better about it and be willing to consider a different standard than maybe the current ones for rot, or understand that it could be better with different materials, or whatever the case may be.
Yeah.
So,
Well, Howie, it's been great to see you. I'm glad we took the time today.
Thanks, Brandon. Yeah.
Thank you. Have a great day. Enjoy the rest of your time at Rapid.
Thank you. Thanks. Look forward to seeing everybody here and at the next event. Take care.